In this part of the lecture, we'll talk about how the DNS can be used as both a conduit and as a target for denial of service attacks, and how DNS can also be used in a so-called amplification attack, whereby an attacker can send a small amount of traffic, which then results in amplification or a much larger amount of traffic being sent or directed towards the victim. Before we get to amplification, let's talk about a very high-profile denial of service attack on the domain name system that took down a large portion of the internet. On October 21st, 2016, a large collection of compromised IoT devices, ironically internet-connected security cameras, started directing attack traffic towards a DNS provider called Dyn. Now, you may not have heard of Dyn, but it's a centralized DNS service provider that provides so-called authoritative name resolution for a large number of websites on the internet, including Twitter, Netflix, Spotify, Reddit, and many others back in 2016. And so an attack on Dyn that resulted in names like Twitter.com and Netflix.com and so forth not being able to be resolved to IP addresses resulted in all of those websites and services becoming unreachable. Here we see a critical example of how the centralization of internet services can create a widespread vulnerability. An attacker didn't need to take down all of those sites. It only had to identify a critical dependency, in this case, the domain name system, and attack that system to bring down all of these sites. This attack was so high profile that it made the front page of the New York Times. The botnet that launched this attack was called Mirai, and the company Dyn posted a very interesting post-mortem on the attack. I've highlighted some of the interesting parts of this post-mortem here in red, and there are a couple of interesting things to note. One is that the attack was such that it was difficult to distinguish legitimate traffic from attack traffic, because the attack traffic itself looked like DNS queries. Another interesting knock-on effect occurred, which was that the attack resulted in a cascading failure, where legitimate queries weren't able to be resolved, and this increased the rate of retries. And so retry or retransmission traffic started contributing to the overall traffic volume seen at the victim servers, thereby increasing the overall traffic that the victim had to deal with. Now, that effect is somewhat of what you might think of as an amplification, but there's a more typical or classical amplification attack that we can look at now that's commonly used by attackers. And the domain name system is often a vector for this amplification attack. In a basic amplification attack, a source or an attacker sends some attack traffic, typically a small packet, and the so-called reflector responds to that traffic by sending a large volume of traffic towards a denial of service target or victim. The example shown on this slide is a so-called Smurf amplification attack using an internet protocol called ICMP. You may not have heard of that protocol, but it's used if you use the tool ping to attempt to reach a particular internet destination. In this particular example, the attacker pings or attempts to send a packet towards a so-called broadcast address with a source IP address that is spoofed to be the IP address of the victim. When a switch sees that particular address, because that packet is destined to a broadcast address, everybody on the network responds. But instead of responding to the attacker, they respond to the source IP address in the original packet, which in this case was the denial of service target or victim. Now, that's a basic amplification attack using ping or ICMP, but such a principle can also be used to exploit the domain name system. In a so-called DNS amplification attack, which is common today, a denial of service source sends a query, again with the source IP address spoofed to be the victim, and that query is typically small, say 60 bytes. The source can craft that query so that the response is in fact large. Some extended DNS responses can be as large as 3,000 bytes. Note what happened here. An attacker sent an initial small packet that resulted in a reply that was almost 2 orders of magnitude larger than the original packet. And so by sending lots of tiny queries, the attacker can use a DNS server to reflect and amplify attack traffic at a victim. If you combine this with some of the earlier concepts we've seen, you can create a distributed denial of service attack where there are many attackers doing this, resulting in an even larger volume of traffic directed towards the victim. Some of the largest DNS amplification attacks have been tens or even hundreds of terabits per second directed at the victim. There is a defense, which is to reject queries from clients that are not on the local network. But of course, this can sometimes cause inconvenience to users who would like to use that DNS server as they move around to different networks and other places on the internet. In summary, DNS is a common target and conduit for denial of service attacks. The centralization of DNS services in providers like Dyn has made the DNS a more attractive target for attack, because by attacking the service, an attacker can bring down many websites that depend on that particular DNS service provider. DNS is also prone to amplification, whereby a small initial attack packet can create a larger response that is directed at the victim, using a combination of concepts called amplification and reflection.